is our scientific method lesson. And as we're talking today, we're going to look at the scientific method. We talked about a little bit of brainstorming yesterday with that. We tried to come up with the 6 steps, and some of you guys were pretty confident with your answer, right? Or your list. And some of you were like, oh, we don't know. We just don't remember. So we're going to go through those 6 steps today. And we're going to use the scientific method to help us solve some problems this semester. I want to emphasize to you that scientific method, the key here is method. This is an organized way to solve problems. It's not the only way to solve problems. It is a single way to solve problems. And as we're doing that, we're going to use these steps kind of as our outline. Now, first step, scientific method. Everybody should have been able to identify this yesterday. What do you got to have if you're going to solve a problem with the scientific method? You got to have a problem. That's right. You got to have a problem. So on your note sheet, you're going to find a place that says 1, 2, 3, 4, 5, 6. Do y'all see it? Mm-hmm. What's the first thing? You got to have a problem. State the problem. And I know that the font color on here is not great. I apologize for that. This is the only screen where we'll really have to strain to see that. So you have to have a problem to solve. This year we're going to give you several problems. And unlike previous years where you've been given a set of instructions and the instructions say, number 1, do this, number 2, do this, number 3, do this. This year you're going to have to come up with your own way of solving some of those problems, which is good. All right, so we got a problem that we're going to work on. What's the next thing? Do we just immediately start working on it?
No.
What do we do first?
Write our names.
No. Write our names.
Design what the problem is.
Do what?
Brainstorm.
I heard somebody say brainstorm. Yes.
Hypothesis.
Well, and even before you hypothesize, what should you do? Yes, ma'am.
Read the directions.
Okay, well, what if you don't have any directions? You don't have any directions. What are you going to do?
Research.
Do some research. That's exactly right. You're going to do some research. So what does that mean? Well, I'm going to tell y'all really quickly a problem that I am currently working on. You know, I told y'all I was in school. And I am working on a problem with the elementary school right now, the primary school that's right across the road. And I don't have a whole lot of experience at the elementary level. Most of my experience is middle school, high school. So I wanted to do something with elementary students for my project. And I'm working with a lady over there whose name is Miss Bates, Annabeth Bates. Anybody know her? Okay, she's an intervention specialist over there. But we're working on a problem with kindergarten students to figure out, first of all, what do you learn in kindergarten?
ABC.
You learn your letters, right? Why do you need to learn your letters? So you can learn to
Spell.
How about read? Gotta read,
Yeah.
right? And so what we're trying to figure out is, does it matter the order that you teach those letters? Is there one order to teach the letters that's better than another order to teach the letters? And so that's my problem. Is this order better? The Mark County School District has an order that they use to teach the sequence of letters to kindergartners. Is there a better way to do it? So we're testing out a different sequence. And this sequence was actually designed by Ms. Bates. So we're going to apply it to these kindergartners and see what happens if some of them actually do better than others. And that'll be interesting. So in order to do that, I had to do some research because I have no idea about why they teach the order of letters in a certain way. So I did a lot of research, and I actually spent a couple of months researching all of the last several years of work that's been done with kindergarten students and first grade students and the sequencing of how they did things. I did research. I used the internet. I used resources from USM, the library there at USM. I looked in educational journals, and it took me a very long time so that I could make A what? Hypothesis. So what is a hypothesis? And I know you've heard this word. And every time you learn the definition of this word, you've learned a hypothesis is an blank blank. What's the blank blank? Raise your hand if you know the blank blank. Yes, sir. Educated guess. How many of you have heard that before? It's an educated guess. Okay? So, what on earth is an educated guess? Discuss that with your table group. What's an educated guess?
Yes, you are.
Okay, so raise your hand and tell me, what is an educated guess versus a guess that's not educated? Okay, is there a difference? Is there? Okay, what do you think, Jacob?
It's when you have researched something and you got information about it before you decided what you think was going to happen.
So, versus,
Just guessing the match off of a whim.
yeah, kind of an eeny, meeny, miny, mo thing, right? Where you really have no clue, you're just going, nah, I think this. Instead, based on your research, and it doesn't even always have to just be on research, it can also be on your experience. You know, I've been teaching 20 years, I've got some experience, right? So based on my experience, based on the research that I've read, now I'm ready to form a hypothesis. And that's what I did. It wasn't just an eeny, meeny, miny, mo type thing. It was based on the literature that I'd looked at, my personal experience, and even the resources at the primary school, these teachers that I'm working with. Okay, so we have a hypothesis. Now what? Raise your hand and tell me what goes next. We just sit there and go, what do we do? We test it. What do we call testing the hypothesis? We do an experiment. Very good. We're going to do an experiment. Do the actual experiment. And again, in the past, for the most part, when we've done an experiment, we've given you a set of steps and said, okay, follow these steps, right? Not going to happen every time this year. This time, you're going to have to come up with how we're going to solve that problem. And I'm not going to tell you exactly how to do it because your way of solving it may be different than mine. So we're going to come up with a set of steps on how to solve our problem. Okay, so as we're working the problem, as we're experimenting, what's next?
Results.
Okay, you're right, results. But raise your hand next time. Results. What are we going to do with those results? What are results? What's another word for results that you collect in an experiment? Yes, ma'am. Okay, you're going to record. Record what?
The results.
Okay, what's another word for results that you're going to record? I'll give you a hint. It starts with a D. I heard it. Data. You're going to collect your data, right? What are you going to do with the data besides record it? What are you going to do with it? Yes, ma'am. Say again?
Graph it
Why would you graph it?
so you can get like a better look at it.
Getting a better look is what I'm getting at, okay? And there's a word we use for that. Getting a better look at, studying something. Can anybody tell me the word I'm looking for? Yes, ma'am. You're so close. We do make observations as part of it, and we use those to collect our data. What? Surveys may be something that we do to collect our data, but how about analyze it? How about analyze it? We're going to analyze the data. We're going to analyze it. And McKenna said, what did you say, make a chart or graph? Make a graph. So one way that we can analyze data is to take the results, put it into a graph form. That helps us to see patterns. It helps us to see trends, right? So as you're analyzing data, you want to organize that data in such a way that it's easy to analyze. What's a way to organize data? To record it in a what? A chart. What else? A graph. So when you're analyzing, it's a good idea to take the data and put it into some type of organized display. That might be a chart, it might be a graph. I'd write that down, I'm just telling you. I'd write that down. So, what's the purpose of analyzing it? I mean, do we just make a graph and go, oh, that's such a beautiful graph? Do we do that? Okay, discuss it with your table group. What do we need a graph for? What do we need a chart for? Discuss that. Okay, I did hear some good points as I was going around the room. What's the purpose of analyzing? What are we doing? I want this guy right here.
To see the results better.
Yeah, to understand the results, right? To make sense of what we've just done. You've got to be able to analyze what happened, to think about it, to ponder, to make sense of what you've just seen. And once we've done that, then we're able to do the last thing. What's the last thing, everybody? Y'all are scaring me now. Come on. What's the last thing you do in an experiment?
State your resolution.
Okay, but we usually don't call it a resolution. What do we call it? We don't call it a solution. We write or draw a conclusion. Y'all are acting like you've never heard this before. Have y'all never heard this before? Raise your hand if you've heard this before. Okay. I'm just having to work really hard to get it out of you. That's all right. I can do it. What's a conclusion? Talk about that with your table group. Talk about that with your table group.
Throw a giant party with fireworks.
Okay, I've heard some good answers as I've gone around the room. So, since you've discussed with your group, that means that everybody's had a chance to hear a good answer. Let's get the bucket out. We got several of you that are like this when they ask a question. We cannot hide from the bucket. We'll get you. So, what is a conclusion? Annalie.
A conclusion is like
I think her nervous system shut down.
It's okay.
a conclusion is like everything put together, like solved.
Love it. Everything put together, solved. Great way of saying it. Say it a different way. Dion.
Well, a conclusion is like your final answer.
Yeah, absolutely. What else? I heard some other words. Rhea.
Final thesis statement.
A thesis. What do you mean by that?
It's like everything like after all the results, you come to this conclusion. Like it's.
You're right. You're right on track. You're answering your question, basically, right? You're summarizing what you've learned, and you're writing it so that other people can learn from what you just did. This is what we did. This is what happened. This is what we think the results are, and here's why. So you're basically summarizing everything and really talking about why you think what you think. Very good. You guys did a great job. Wonderful. Very good. All right, so we're going to take these steps and we're going to use them to solve problems this year. But we also have to be able to speak the language of science. Who in here has ever been to another country before? Anybody? Where have you been? South America. Where have you been?
India.
India. Anybody else been to another country? Where have you been? The Bahamas. Where have you been?
The Bahamas.
Bahamas. Okay. So some of us have been to other countries where they speak a different language. And I don't know about you, but it can be very intimidating when you go someplace and they don't sound like you do, right? We've only been we've been to Canada, but my husband and I we celebrated 25 years of marriage and we did a cruise. So we went to, I don't remember.
Mexico.
Yeah, but there was a place we went. There were two places. Cozumel and
Puerto Rico.
No, that's something.
Cozumel and
Costa
something
Rica.
else. It wasn't, no.
It starts with a C.
Yeah, it was another C word. But anyway, that's beside the point. We went two places and they didn't talk like we did, okay? So fortunately, there were people that talked English or spoke English, and that made it easier for us. But if we got down there and we didn't understand anything, we would be in bad shape. Y'all agree? Science has its own language. If you don't know the language when you read scientific material, when you read somebody else's research, it won't make any sense to you. So you've got to know the language, the terminology. So we're going to focus on 4 words today that are involved in experimentation. You're going to see these words over and over as you continue your education in science, and I want you to understand the language. I hate to say we're going to do vocabulary, because when I say that, everybody glazes over like, oh my gosh, we're doing vocabulary. But this is important. We're going to do it in reverse. Instead of me giving a definition to you, we're going to look at how the words work first, and then we'll go back and we'll come up with our definition. Does that make sense? All right, your blank sheet of paper, take it out. If you would, please. Fold it hamburger style. Before you fold it again, hold up. Okay, so here's our hamburger style. We had some people last class period that were what I call paper challenged. They couldn't fold their paper, so watch if you're confused. Then we're going to do hot dog style, like this. Hamburger hot dog. Yes, sir. Yes, you did a good job on that hamburger fold there. Good job. All right. So when you open it up, instead of having 4 squares, if you turn it sideways, which in ICT we call this what? Landscape. Thank you. Little ICT integration there. Fold it landscape so your holes are on top. And we have 4 columns. Does everybody see that? 4 columns. That's how we're going to do it. Good job. Now, 4 columns, guess how many words? 4 words. But we're going to talk about these words with a specific experiment. And this experiment really has been inspired by my dad because he did a lot of gardening, whole lots of gardening. And he lived in Summerall. So how many of y'all have gone to Summerall and then to Bassfield from Summerall? Okay, if you go into Summerall, turn left like you're going to Bassfield. My dad lived in what's called Melby, which is about 7 miles out. It's right on the county line. He grew up there, and his mom and dad had about 160 or so acres of land, and so my dad inherited part of that. And he has a big garden every year. As sick as he was last year, we had a huge garden over the summer. And my dad's nickname in the family is Mater Man, or Tomato Man. Mater Man. We would call him Mater Man because he could grow the biggest tomatoes you have ever seen. And I am not saying occasionally he'd get a big tomato. I mean, all of his tomato plants would have these honkin' tomatoes hanging off of them. Who in here likes tomatoes? Okay. I love them, and of course in the summertime there's nothing better than a tomato sandwich. Who in here likes tomato sandwiches? Ooh, they are so good. Like fried greens. It's not as good to me as tomato sandwiches, but my dad's tomatoes are so big that when you slice them, one slice makes a tomato sandwich, just one slice, because they're huge. And of course, you need a little salt, pepper, and toast bread. It's really good that way. But anyway, we called him Mater Man. And my dad, even though he wasn't a scientist, he really approached gardening from a science perspective. He would always be experimenting, trying to figure out what would make the tomatoes grow better, or this, I don't know, different crops, what would make them grow better. So we're going to look at a problem that my dad would have probably asked himself maybe several years ago, because he was way beyond this later in life. But the problem we're going to look at is very simple. So I want you on your sheet of paper to, across the top, when I say the top, we've turned our paper like this now, right? So where's the top? Where the holes are, okay? So you're going to write your problem across the top. And the problem we're going to look at is this. Which fertilizer causes tomato plants to grow the best? Just write it across the top. Which fertilizer causes tomato plants to grow the best? Now, no matter what experiment we're talking about, we're going to go through and identify 3 or 4 things. So I've got 4 columns on our paper, and here are the things that we're going to be looking for. What is the independent variable? So write that in the first column, underline it. So we're going to write some things underneath. What are the constants? What is the control, if there is one? And what is the dependent variable? What I want to do is use the experiment to help explain those things, and then we'll go back and do some definitions. And the reason I'm going to do it backwards, is because I don't want you to just memorize the definition. Y'all, several of you have memorized your way into 7th grade. Am I right? You'll memorize it for the test. 5 minutes later, you forgot it all. Don't tell me you haven't done it, because I know you have. I've done it too. Okay? Just because you memorize something, does that mean you know it? No. So we're not going for memorization so much this year. We're going for understanding. Understanding. Okay. So as we think about these things, we're going to start off with our independent variable. Yes, sir.
Do you have a pencil sharpener?
I do, right here. Okay, so everybody caught up? Caught up with me? Very good. Independent variable. The independent variable is what the experimenter is going to change or test in the experiment. So let's look at the question. Which fertilizer causes tomato plants to grow the best? What are we going to change in this experiment? What are we going to test? What? The fertilizer. That's exactly right. So under independent variable, in parentheses, I want you to write a key word to help you remember this. The independent variable is the variable that we are changing. It's what the experimenter is changing. In this case, our independent variable is the what? Fertilizer. Not just fertilizer, but we want to know which fertilizer. So we're looking at the type of fertilizer. Now, y'all, I have terrible handwriting. I'm not even going to try to tell you I have great handwriting. I think that's the sign of a true scientist. However, it's no excuse for turning something in that I can't read, okay? So you've got to write where I can read it. But the other thing is, when you're writing notes for yourself, do you have to spell everything out? No, I mean this is just notes, right? So abbreviate when possible, as long as you know what your abbreviations mean. When you're turning something in for an assignment, though, spell it out because I may not know what your abbreviations mean. Okay, so the type of fertilizer is what we're going to change. The second word on our list is the word constant. And the key for the word constant is something that we're going to keep the same in the experiment. We're going to keep it the same. So let me ask you a question. If we're going to try to figure out which type of fertilizer makes the plants grow the best, what is something that we should keep the same in the experiment? Yes, sir. Sir? The plant itself. So in this experiment, should we use tomato plants and pea plants and carrots and, okay, we're going to keep the type of plant the same. Why would we need to do that? Think about that. Why? Yes, ma'am.
Because maybe different fertilizers may have different effects on different plants.
You're exactly right. So something we're going to want to keep the same is the type of plant. In this case, what type of plant are we going to use? Tomato plants. Very good. What's something else that we should keep the same, that we should not change? Jacob?
The location.
What do you mean by that?
How much sun the plants are getting.
Very good. Y'all agree?
Yes.
If you change the amount of sunlight, you might cause the plant to grow just from the difference in sunlight, right? And not from the fertilizer alone. Very good. Anything else that we should keep the same? Yes, ma'am.
How much water and stuff?
Very good. The amount of water would need to stay the same. Really quickly, discuss with your table group and see if there's anything else you can come up with. Besides those three things, is there anything else that needs to stay the same in our experiment?
No, there's one.
No, all plants.
There's one. But they were talking about this specific.
Yeah, it's
So for this
We need sun and water and air.
Okay. Now that we've discussed with our group, that means you should have at least one thing that you can add. So, let's see what you came up with, DJ. What's something we should keep the same? The soil. When you say the soil, what do you mean by that? Okay, the type of soil. Would y'all agree there's different types of soil?
Yes.
Some sandy, some clay-like, some dark, rich soil. So yeah, the type of soil. I agree. Add that to your list. Okay. Let's see. What about Meredith?
How much soil?
How much soil? Do y'all agree with that? If you put just a little bit of soil in the pot versus a lot of soil, can that affect the plant's growth? Okay, so the amount of soil we want to keep the same. Anything else that we haven't mentioned so far? Yes, sir.
Well, this kind of touches on what Meredith said, but the soil to fertilizer ratio, how much of this you're going to put in there and how much of this you're going to put in there.
Okay, so let me ask you this. We're going to change the type of fertilizer, but are you saying we should keep the amount of fertilizer the same? Do y'all agree with that? Would that have an effect on how the plants grow?
Mm-hmm.
If we just put a little fertilizer in one and we put a lot in another, could that cause different results?
Yes.
So we would definitely want to keep the same amount of fertilizer. Good. Anything else? I can think of two other things. What about the container that we put it in? Does that matter?
Yes.
Or does it?
It does.
Why do you think that matters, the container, Hudson?
The amount of room that
Yeah. Room for the roots to grow, right? So the container would need to stay the same. You want to use the same type of container or same size container. What else? I see a hand going up back there, Tavia.
the container. I mean, not the container. The iron bars.
The what?
The iron bars.
My dad, when he grows tomato plants, he puts these bars around them so it won't grow out.
It's like a cage that they support them with. Yeah, I know exactly. My dad used those too, because when your plants get really big, they can lean to the left, and especially if you're growing some honking big tomatoes, they can lean. So the cage or the thing that you're surrounding the plants with. So yeah, that wasn't what I was thinking, but I'll add it to the list. I'm going to just call it cage. Does everybody know what I mean by that? Okay. What about, yes ma'am? Oxygen, okay. So what do you mean by that?
Like, if you have clean air the first time you
Okay, so the environment that you're putting it in. I wasn't thinking so much oxygen, but what I was thinking goes along with what you were saying.
Weather and climate around.
Yes. So what I'm thinking is temperature, okay? We can do it in a controlled environment. And I think that's really what both of you are getting at, is putting the plant in a controlled environment. So let's say it that way. We want to control the environment. I was going to use the word temperature, but I think if we say controlled environment, it incorporates both of what you've said. So good. Yeah.
I have a question when you said the same amount of fertilizer.
Uh-huh.
My granddad, before he passed away, he would grow blueberries, and every year he would do a different amount of fertilizer, and his blueberries would get bigger and bigger and bigger.
Sounds like a little experiment going on right there as well. Now, I can't speak to that because I haven't tried that experiment yet. But I do have blueberry bushes in my backyard, so I may keep that in mind for this year. See if we change that. All right, well, I think we've come up with a good list of things that we need to keep constant. But here's the question. Why do we need to keep all of these things the same if we are changing the type of fertilizer? Why? Would you talk about that with your group for a minute? Why do we need to do that?
You do you got to see
All right. So tell me what your group came up with. McKenna.
You want to keep it all even because if you give one thing more to another, it's obviously going to grow better. Like more sunlight, more water. It's all you need to keep it the same so you can test the two fertilizers better.
If we don't keep these things the same, we're not going to know whether it's one of these things that caused the change or the fertilizer, right? So how are we going to measure the change? We're going to skip over to the last term on our list, which is the dependent variable, okay? And the key word for dependent variable is the word measure. Here is how we're going to measure what changes. The dependent variable depends on the independent variable. Go ahead and draw that in. Depends depends on the independent variable. Okay? So let's think this through. Our question again, which fertilizer causes tomato plants to grow the best? We're going to change the type of fertilizer, but how are we going to measure the success of that fertilizer? What are we going to measure to tell us which type of fertilizer worked the best? What are we going to measure, DJ? Okay, be specific. What about them?
See how big they got?
How do you measure bigness? A ruler to measure what? When you say how big, what do you mean? What do you mean when you say big? What? The height. Does everybody agree with that? Okay, we can measure the height of the plants. Great. The height of the plants would be our dependent variable. It's how we're going to measure whether these fertilizers are effective or not. Okay? Now, I was going back to DJ several times because he used several words that were great words, but we've got to be specific in how we're going to measure something. Otherwise, we're not going to be able to tell whether or not our independent variable is effective or not. Yes, sir.
I was thinking it really would depend on what you meant by best, because while the height of the plant could have been big, but it could have made tomatoes that weighed more, so that would mean there would be more of that tomatoes.
So if I make the problem statement, and I did that on purpose. I'm so glad you caught that. Which fertilizer causes tomato plants to grow the best? We would have to really define what we mean when we say the best. In this case, we're defining it as the height of the plants. But especially in tomatoes, maybe a different way to define that would be the size of the tomatoes. If that was the case, I probably need to change my question up to be a little more specific. Does everybody understand that? Okay, listen, y'all, hold on just a second. Go ahead.
Oh, I was gonna say, you can measure the mass.
The mass of the plants, that's exactly right. Although, to do that, we'd probably have to take them out of the ground and put them on a scale, and that would hurt the plants. So, maybe not as good as doing the height of the plants in this particular experiment. But certainly we could measure their growth that way. You're right. All right, we have one word left, and that is the word control. Control. And the key for control is the word compare. Compare. Before we talk about what a control is in this experiment, I want to explain it to you with another experiment that I think will make more sense, and then we'll apply it to this one, okay? How many of you have ever seen commercials on TV advertising drugs? I'm not talking about illegal drugs. I'm talking about like this medicine. You take this medicine and it will help you, get better in this area, okay? And at the end of the commercial, they always say, take this wonderful medicine, but if you do, you could get this or this or this or this or this. Y'all know what I'm talking about? Yes. So you really don't want to take it after you've heard all the bad things about it. But my point is this. How is it that they can get on there and say this medicine will help you help your cholesterol or help your high blood pressure or help, let's say, fix the cold that you have? Okay? Right now we don't really have a medicine that fixes or that treats. Let me rephrase that cures a cold. Cold is a virus, and so pretty much we treat symptoms. We don't you don't get a cure. But what if I said I have a cure for the cold? How could I prove that? How can I prove that? What do I have to do to prove that? Talk about that with your table group real quick. What would you have to do? Okay, so how are we going to test this? I have come up with a medicine, and I'm telling you that this medicine will cure your cold. How could I prove that? How could I prove that? Troy?
Test it
How am I going to test it?
on somebody.
On somebody. Would I just test it on one person?
No.
Different people. Okay. So there has to be something more to this. Ashley.
I was gonna say test it on one piece.
And she's right. A lot of drugs get started. One of the initial tests is done on animals. They do animal testing before they do human testing. So you're right. But let's say we're beyond that. Okay, we're past the animal testing stage. What are we gonna do? What are we gonna do? I thought you had it on.
I was just gonna say that scientists do tests on rats all the time
Mhm.
while they test stress on rats for different types of experimental research
Mhm.
that they do for different types of things.
Yes, the rats get hit a lot with, with experimental drugs and things. But we're beyond the rat stage now. So what are we gonna do next? Yes, ma'am.
Well, I had like two methods. Well, like if you were a scientist, and like the doctor created this pills thing, you could like take a microscope and you can like look through it and like look at all the substances, the chemicals and stuff that they use and stuff, and then you can like test it like, you know. And then my other method is you could like when you go to the doctor, you can check ups and stuff. So they can check you for like anything like after they do the pill thing. They can check
Okay,
you.
so somebody's got to take the pill, right? So do we just have one person take the pill and then all of a sudden they get better and we're like, okay, yes, this works. What do we do? All right, help us out. Yes, ma'am. Compare what? Okay, well, let's suppose there is no other medicine. There's no other medicine out there right now that says they cure the common cold. So how are we going to test that? Yes, ma'am.
You can test it on different people since different people have different immune systems.
Okay, so let's suppose I round up 100 people. Okay, these 100 people all have a cold, and I want to test this medicine. I'm going to split that group into two groups. Okay, and I'm going to give my medicine to 50 of them. What am I going to do to the other 50?
Get in a different kind of medicine.
Okay, but then how am I going to know whether my medicine is really what's right? So let me back up a second. I've got 100 people. Half of them I'm giving my medicine to. What am I going to do with the other half?
Give them your medicine.
Yes, ma'am.
You can see the side effects that the other medicine has on the people that you gave to, or that you gave the different medicine, and the side effects that it has to the people you gave to, that you gave medicine to.
Okay, I got lost at the end of what you were saying, but you're talking about side effects. We would need to be able to look at side effects. So maybe there are some, but again, my group got the medicine. What about the other group?
You don't get any.
No medicine. Why do I need a group that didn't get the medicine? Raise your hand and tell me. There's a real good reason. Yes, ma'am.
So you can compare them.
Yes, you have to be able to compare people that got it to people that didn't, because eventually everybody's going to get over a cold, right? Your natural immune system is going to take care of it. Unless there's something wrong with your immune system, you're eventually going to get over a cold. Your body will fight it off. What we're trying to see is, do these people that got the medicine, that received it, are they going to get well faster than those that did not? So the group that got the medicine, they're the experimental group. The group that did not get the medicine, they are the control group. We're going to compare those that got it to those that didn't. Do you see how that works? Okay. Sometimes instead of separating two groups like that, a drug company will say, all right, I'm going to split these people into two groups. This group we're going to give the medicine to. This group we're going to give a fake pill to. It's called a placebo. And it would be like a sugar pill. Okay? Are you going to get well from a cold by taking a sugar pill? No. But they think they're getting this medicine. And so we're trying to see if, are they really getting better because of the medicine? Or are they getting better because they think they're getting the medicine, right? That's a placebo effect. So the point is, we got to have some people take it. We got to have some people that don't, so that we can compare the two. So the group that doesn't get the medicine, they are the control. Everybody say control. Control. They're the control. They're the group that we use for comparison. Now, let's think about our experiment. What would be the control in this experiment? What are we going to compare the plants that got the fertilizer to in this experiment? Would you talk about that with your table group?
Sounded like a yeah, I know it's
We didn't even say I think Taisha. She's got it. All right, Taisha. What's going to be the control?
Well, if you take you can take two plants and use different fertilizers and see if
Helper group.
One without the fertilizer and the one with the fertilizer.
see which
it
one.
really grows.
Okay, so they're going to use for a control plants that get what? No fertilizer. Why do we need plants that get no fertilizer? Think about it. Why do we need plants that get no fertilizer? There's a very good reason for this. Why? Why do you think, Rhea?
To see how the fertilizer affects the plant.
Well, let me ask you this. Are plants going to grow if you give them sunlight and water?
Yeah.
They're going to grow anyway, right? So how are we going to know whether they're growing just because they're getting sunlight and water? How do we know if it's that causing them to grow or it's the fertilizer causing them to grow? Do you think every fertilizer causes plants to grow better?
No.
No. I mean, they might say it does, but how do we know? We don't. So we're going to need a group of plants that get no fertilizer. Okay? They're going to be our control group. Plants with no fertilizer. Just like the people in the drug experiment that didn't get the medicine are the control group. The plants that don't get the fertilizer are the control group. Why? So we can compare plants that got fertilizer to plants that did not. Does that make sense? So the control is what we're using for comparison. All right, so really quick, our independent variable is the thing that we're going to do what?
Change.
Come on, going to do what?
Type change.
Change. And in that process, how many things should we change? One thing. Everything else needs to stay the
Same.
And those are called
Constants.
constants. Very good. So that we can measure our dependent variable, which depends on what?
The
Independent variable. And we're going to use a
Control.
control to compare the dependent variable to just see if our independent variable really is what's causing the change. Does that make sense?
Yes, ma'am.
Okay, we're going to do a booty break, pair share. So here's what we do. We pick up our paper. Who wasn't here yesterday? Okay, one, and you weren't here yesterday either. Okay, so you weren't? You weren't here yesterday. All right, so really quick, how do we pair share? Somebody tell me. Okay, Taisha's got this. You go, girl.
Everyone get in the middle, and you get your friend who's on the outer side, you share, and you collect your seat.
Perfect. And when do you start?
When you say,
Oh, yeah. What's my word? No. What's my word? Ready? Go. See? Okay, so we're going back to now put in our definitions, okay? Yes, definitions are important. They really are, but I don't want you to just memorize the definition. I want you to understand the word. So I'm hoping that we have an understanding of the words now, and we're going to go back and add our definition to it. Does that make sense? All right, so what's our definition for our independent variable? It is a single factor that the experimenter, what? Changes. What did we say our key word was for independent variable? Changes. Okay, would you please circle the word single? Circle it. What does single mean? One. If you don't know what that means, it's lonely. Yeah, one. It means one. So above there, if that doesn't automatically come to your mind, you better write that down, because we're talking about changing one thing in the experiment. One thing in the experiment. And that's what we're changing. The independent variable in the experiment we talked about was the different types of fertilizers. Okay? Then we talked about the dependent variable. What's the dependent variable? Number 5 on your list. The factor that will be what? Measured. That's our key word. Very good. And we know the dependent variable depends on, that's why they call it dependent, depends on the independent variable. That's okay. You got it, Croy. In our experiment, we were measuring the growth of the plant, specifically height. That's how we were measuring. DJ was helping us get that honed in so we could know for sure how we were going to do that. And then we talked about our standard that we're going to use for comparison. What word is that?
Control.
Control. Number 6 on your list. The control is our standard used for comparison. Keyword, compare. And a control can be a single thing, or it could be a group, like in our drug experiment we were talking about. This group of people represents the control. This group of people represents the experimental group. Be a group. In our experiment with our plants, the control was the plants that do not receive any type of fertilizer. We're comparing the ones that did get it to those that did not. And then finally, the last term that we need to be able to identify in our experiment are things that are constants. A constant is a factor that stays the same. Very good. Throughout the experiment. And we listed a lot of constants for this experiment. Just a couple that I mentioned. The amount of water, the temperature, soil type, and the container size. Okay? So, are we feeling pretty good about those terms? Okay, great. Then take your 4-column page and flip it over to the back. We're going to do one more experiment. We're going to see if we can identify apply those 4 terms to another experiment. But this time we're going to come up with our own. I'm not going to give you one. You're going to come up with one on your own. Okay, so first, before we come up with our question, let's go ahead and label our columns with our 4 terms.
Independent variable, constant control, and dependent variable.
You got it, Croy. Fill it in. Croy is flung it. He's got it. And let's see if you can come up with your keywords. Don't say them out loud, just add them. See if you can do it without looking. Ryan, I don't have them on board here.
No, I thought you were talking about
Oh, I can.
the words.
No, I was talking about the keywords. Like, what's our keyword for? You were trying to do just what I said. I appreciate you. Bless your heart and sit like that. Okay. You have them? What's our keyword for independent variable, everybody? Change. Constant.
Same.
Control.
Compare.
Dependent variable.
Measure.
Very good. Good job. Okay, so now we've got to come up with a question. And what I'd like for you to do, let's make our question have something to do with plants again. Let's kind of stay in the same general, with the same general idea. Can anybody just come up with another problem? I mean, not anything to do with fertilizer necessarily, but something different that we could do related to plants that could be a good problem for us to solve. Okay? No one is willing. I'm going to go for the bucket if I do not get a volunteer. Okay, Jacob is going for it.
Do different amounts of sunlight affect the taste of food?
Affect the taste. Now, let me ask you this. That's a great question, first of all. Second, though, is taste something you can measure?
Well, it would be more of an opinion.
Yes. So when we're designing our experiment, wonderful idea, but we want to design in such a way that we can measure our dependent variable. It'd be very hard to measure taste, rather. But is there something else we could do with sunlight? Can anybody take what Jacob started there and maybe change it where it would be something measurable? Hudson?
The effect of the color
What color?
of the food.
Color of what? I think you got a good one going there, but go ahead and give it to us, the whole thing.
When sunlight affect the color of a fruit or vegetable.
Does sunlight affect the color of a fruit or vegetable? Okay, that might be something. Is color something that we can measure? I mean, we could say, you know, we have to come up with a code or a way of measuring like different shades of orange or different shades of red or green. So maybe that might, again, be hard to measure. Have you got one?
Oh no, I was just gonna say, or you could add like some different types of chemicals to alter the color of.
Yes, absolutely, because that can change the color of plants. Okay. So what about you, Rhea?
How about like the different climates that you grow the plant in,
Okay. Pick a specific thing you want to test.
or like pull a plant in the desert and you pull the other plant in the very soil dirt,
Okay. So
like soil.
how about if we just go with soil? Different types of soil. Is that something that you think we could be able to measure the result of?
Yeah.
What would we measure? Okay, so let's kind of work on that one. Tavia, you've got one too. We may go with yours. Let's hear what yours is.
Does the amount of sunlight change the height of the vegetable?
Okay, it changed the height of, I wouldn't say the fruit, change the height of what?
The fruit, the vegetable.
And she's talking about what the plant produces, but I think we could even go with the height of the plant on that. Does the amount of sunlight
Affect the height of the plant.
very good. What do y'all think about that one? All right, so she kind of took Jacob's idea, put in something that was easier for us to measure. Okay, so Rhea, if it's okay, we're going to go with Tavia's. I think that'll work. So Tavia, say it again.
Does the amount of sunlight affect the height of the plant?
Love it. Okay, now question. Is it effect or affect?
Affect. Affect.
Affect is the verb, right? Does the amount of sunlight affect the what?
Height of the plant.
Height of the plant. Okay. Good question. So, with your table group, I would like for you to identify the independent variable, the constant, the dependent variable, and I would like for you to leave the control alone for right now. Okay? Leave the control alone, but I want you to talk through the other three terms with your table group and write on your paper what you think. All right? Go for it. I have blanked out the screen, but I'm going to go ahead and put in here the answers so that if you're at home you can see what they are. Our independent variable here, the thing that we're testing, is the amount of sunlight. And we'll have to define how we're going to measure that. So maybe in hours. Some things that would have to stay constant are very similar to what we came up with before. Things like the soil, amount of water, the container that we use with the plants. If we're going to use the fertilizer, the type of fertilizer that we use, the amount of fertilizer. And there's probably some others we could come up with as well. Our dependent variable is going to be what we're measuring. And that's even spelled out in our question. We're going to be measuring the height of the plant again. In this case, it's really hard to pick a control because you can't have a plant grow without sunlight. Now, it may grow a little bit, so we could technically say a plant with no sunlight, but in every experiment, there isn't always going to be a control. So in this experiment, because pretty much your plants aren't going to grow without sunlight, we could even say that there isn't a control for this experiment. Okay, this is going to end up our lesson for today. We're going to finish discussing as a group. I'm going to go ahead and stop the recording. And again, this is a Scientific Method introduction on January the 7th.